This nice report came out just recently, and as usual, I save every interesting paper, report, news item, and so on in folders that I will eventually get to. So this is already 8 months old, but the results are fantastic. It's a report on decoding India's changing monsoon patterns, a tehsil level assessment by these people from the CEEW, the Council for the Environment, Energy and Water. It's a you can read more about them when you if you wish. I will take many figures from the report but focus on reading the executive summary, which captures most of the ideas. The monsoons are crucial for the Indian economy and are often regarded as the backbone of the agricultural sector, which employs over half of India's population. We have two monsoons, the southwest and the northeast, or the summer and the winter. 76% of the annual rainfall comes in the summer monsoon, during the summer monsoon, and the rest during the winter monsoon and some pre-monsoons and so on. The idea of mentioning how many people are employed in the agricultural sector is important, because often industrialists, very smart people according to their own claims, say that agriculture only contributes 25% to the GDP, but it's a backbone of employment. Obviously that means a lot of low paid jobs, but you cannot count GDP versus the contribution to society just by counting pennies. They also play a pivotal role in the management of water resources and the generation of hydro-based clean energy. However, the variability of the Indian monsoon and the associated wet and dry conditions have direct impacts on socio-economic aspects of the country, including gross domestic product, and you can find many good papers on that. In 2022 alone, Asia witnessed over 81 natural hazards, with 83% of them being hydrometeorological. So droughts can be counted as meteorological, just rainfall deficit, hydrological, where you look at river flows, and hydrometeorological, agricultural, ecological, and so on and so forth. India in particular incurred significant losses primarily due to floods caused by the monsoons. While the Indian monsoons by nature show high variability through space and time, current climate change trends indicate that we are likely to breach global warming records earlier than expected. That's the 1.5 degree C goal. Thus, we need to answer the crucial question of how these changes are likely to affect the variability of India's most critical climatic phenomenon, the monsoons. This report doesn't get so much into models, but unfortunately the models don't do so well. The historical trends and their future projections are essentially unreliable. Existing literature predicts intensifying monsoon seasons with increased rainfall in core monsoon regions in the medium term, so up to 2050, and long term as well, up to 2100. Just to mention, up to 2050, 2040 or so, model uncertainties, internal variability dominates the projections, and out to 2100, scenarios that are assumed for simulations end up being the biggest uncertainty. I have podcasts on that you can follow up. So basically I wouldn't believe the models for that far into the future. So capturing short-term granular spatial variabilities has been a challenge, especially beyond the district level. So India has states, districts, and then what are called talukas or tehsils. Existing assessments often focus on prolonged long-term trends at course resolutions and have not been able to account for intricate nuances within seasons spanning across months and days, or even variations within a single district. So the patchiness of monsoon rainfall is stunning, and I will mention this again when we look at the figures. To fill this gap in enhanced analysis of short-term variabilities and to untangle the intricacies of the Indian monsoons, we conducted India's first sub-district level monsoon variability assessment. Sub-districts in India are known as tehsils, talukas, mandals, circles, and subdivisions. However, also referred to as blocks in some scientific literature. However, we refer to them as tehsils in our study to align with the prevalent usage of the nomenclature across the majority of the country for the administrative units. We answer how rainfall patterns are changing across India during the southwest and northeast monsoon in terms of interannual variability, so year to year, intra-annual, so changes within months, wet and dry extremes. So here just a blurb: 55% of tehsils in India witnessed an increase and 11% witnessed a decrease in southwest monsoon rainfall in the past decade, 2012 to 2022. We'll come back and look at the figures in a minute. So this assessment we utilized we utilized the most recent 12-kilometer high-resolution reanalysis data sourced from the Indian Monsoon Data Assimilation and Analysis Project, or IMDAA. Reanalysis, if you don't know, I have podcasts on it, but basically you merge models, numerical models of weather and climate with data. Data have gaps in time and space. Models are not perfect. You blend them to reconstruct or provide a dynamically interpolated data set over a certain period. This one goes from 1979 onwards. The 12-kilometer spatial grid covered 4,419 tehsils out of 4,723 tehsils as per the Survey of India shapefile obtained. That's a GIS terminology. Our assessment delves into trends spanning the past 4 decades, so 1982 to 2022, with a specific emphasis on quantifying changes in rainfall in the past decade, so 2012 to 2022. During the southwest monsoon, or the JJAS, since it occurs from June to September, and the northeast monsoon, referred to as OND because it's October to December. We undertook a geospatial climatological analysis employing established statistical criteria and indices endorsed by the World Meteorological Organization and the India Meteorological Department to accurately assess and quantify these changes. Let's go ahead and read key findings. In the past 40 years during the southwest monsoon, we found that India as a whole experienced 29 normal and 8 above normal, with 3 below normal monsoon years. There are definitions: long-term average and deviations of 20%, sometimes 10% is used by some people. However, analysis of these trends at the district level showed that approximately 30% of India's districts witnessed a high number of deficient rainfall years, and 38% witnessed a high number of excessive rainfall years. So averaging over space has serious issues in terms of interpretations, especially trying to relate it to dynamics and causes and land use. Of this, 23% of the districts such as New Delhi, Bengaluru, Nilgiris, Jaipur, Kutch and Indore witnessed both a high number of deficient as well as excessive rainfall years. So some places are seeing heavy extremes on both sides, and some are going in one direction. Decoding these trends at an even more granular level, we found that 55% of tehsils witnessed an increase in southwest monsoon rainfall in the past decade, so 2012 to 2022, by more than 10% compared to the climatic baseline. So that's the excess deficit definition. Baseline here is 1982 to 2011. A statistically significant JJS rainfall increase was observed in the traditionally drier tehsils of Rajasthan, Gujarat, central Maharashtra and parts of Tamil Nadu. So northwest India and Pakistan extremes have been related to wind shifts over the Arabian Sea and I have been part of a team which has been arguing that the shift in the winds are related to the rapid warming over the Mediterranean and the Middle East, but there are other ideas of how it happened. Nonetheless, while the decreasing trends in in southwest monsoon were not statistically significant continuously over 40 years, we found that nearly 11% of the Indian tehsils witnessed a decrease, particularly in the past decade, by more than 10% compared to the climatic baseline. These are in the Indo-Gangetic plains, which contribute to more than half of India's agricultural production, northeastern India and the Indian Himalayan region. These regions also host fragile but highly diverse ecosystems. Of these tehsils, approximately 68% experienced reduced rainfall in all months from June to September, while 87% showed a decline during the initial monsoon months of June and July, which are crucial for the sowing phase of the kharif crops. So there are scientific dynamic climate issues about how the rainfall is changing in its onset, withdrawal, evolution, distribution of rain, duration, frequency, intensity of extreme events, and so on. And then there is the issue of how the changes in the distribution in space and time affect the agriculture and food production. In our study of localized wet rainfall extremes, we found that nearly 64% of Indian tehsils experienced an increase in the frequency of heavy rainfall days by 1 to 15 days per year in the past decade during the southwest monsoon. This pattern is prominent in the tehsils of states with the highest GDPs: Maharashtra, Tamil Nadu, Gujarat and Karnataka. Furthermore, we found that in the tehsils experiencing an increase in rainfall during the southwest monsoon, the excess is coming from short duration heavy rainfall events. Okay, so duration, frequency, intensity, it's not just the total rainfall, how it gets distributed and where it falls. Rainfall associated with the northwest monsoon, OND, which primarily impacts Peninsular India, has increased by more than 10% in the past decade in approximately 80% of the tehsils in Tamil Nadu, 44% in Telangana, and 39% in Andhra Pradesh respectively, all eastern states. While remaining Indian states are usually dry during this period, we found a statistically significant increasing trend in the OND rainfall along the tehsils of Maharashtra, Goa on the west coast and Odisha and West Bengal on the east coast. This increase could partially be attributed to cyclonic activities in the Arabian Sea and Bay of Bengal. There is arguments made for increasing cyclonic activity. We have two cyclone seasons: the pre-monsoon, March, April, May, and October, November, December. Furthermore, the analysis of monthly variability indicated that nearly 48% of tehsils in India saw an increased rainfall in October by more than 10%, which could be due to the delayed withdrawal of the southwest monsoon from the subcontinent. So essentially, the withdrawal of the southwest monsoon or the summer monsoon is changing, and maybe the onset of the OND monsoon is also changing. Either way, the boundaries are getting blurred, and then you have to again understand the impacts of those on water resources, agriculture, and so on and so forth. So let's leave this here and come back and look at a bunch of really nice papers which raise many good questions about the drivers of these changes as well as the impacts of these changes, as we said, on not just water and food, agriculture, but also energy, transportation, infrastructure, health, and so on and so forth. So see you in the next podcast with continuing discussion of this decoding the changing monsoon patterns in India's monsoons. Okay.